All right, next up, we'd like to take a look at volume, and and since many of our nuclear facilities, doesn't matter if you're going accelerator or nuclear reactor, we have cooling systems, we have water, we're heating up water, cooling down water, boiling water, doing all kinds of things with water. We also have diesel fuel and all kinds of other fluids that we need to concern ourselves with the volume. We have radioactive gases, and we're concerned with how many microcuries per milliliter, another volume measurement. So we need to talk a little bit about volume, make sure we understand what volume is. So a simple problem I have on volume is just, can you find out how many gallons are in a certain tank with a certain measurements? So let's say we have a rectangular tank, and we're going to say that this tank is 3.5 feet wide, and it happens to be 3.5 feet tall, and it's 5.5 feet long. And I would like to know how many gallons of diesel fuel would this hold? So we start off again, we say, oh, gallons. We want to have gallons, all right? So starting out our conversion factors of gallons, we say, all right, I would like to know gallons, but what do I know about gallons? Well, we have you have a conversion factor, know the conversion factor that 1 cubic foot is equal to 7.5 gallons. So coming back here, really I shouldn't have wrote a 1 up in front of here. I know I want to keep gallons, and I know that there's 7.5 gallons in every 1 cubic foot. Now some of you will want to say, okay, I know that volume is equal to length times width times height. So you've heard that since 7th, 8th grade. And so we've got our length, we've got our width, and we have our height, and we can just multiply those together for our volume. And a cubic foot is a volume. And so in our railroad tracks, we can just do this right in our railroad tracks. Say, okay, we're going to multiply, since we have cubic foot in the bottom, if we multiply by a foot, by a foot, by a foot, that'll make up a cubic foot. So we can take 3.5 feet, multiply that by 3.5 feet, and then multiply by our length of 5.5 feet. And what happens here is we can cross all these out. 1 foot up the top will cross out and make that foot squared in the bottom. We can cross out another one at the top, and now we just have 1 foot left, and we cross out another one, and now the whole thing is gone. And so if we multiply 7.5 times 3.5 times 3.5 times 5.5 and divide by 1, we'll know exactly how many gallons this tank will hold. 7.5 times 3.5 times 3.5 times 5.5. Turns out that this tank would hold 505 gallons of diesel fuel. So, not too complex problem, but to get you in the idea of thinking that you can measure just about anything, measure the dimensions of anything, come up with cubic centimeters, cubic feet, cubic whatever, and slowly turn it into gallons, which we normally think of more for fluid. Okay? So let's go on to more of a nuclear example here. And since, again, we're processing a lot of water, we would like to know a lot about water. So let's say we have this pump. So this is a suction of a pump. And here's the discharge of the pump. And the discharge of the pump is going to discharge into this cylindrical tank. So this happens to be a cylinder. So we've got a diameter here. And a height over here. And we look at this tank and we're going to find out the diameter of this tank is 10 foot wide. And even if this was pretty well to scale, we'll just say it's about 10 foot tall. And this pump over here is going to be pumping 75 gallons per minute. And I want to know how long will it take to fill this tank with the pump. So we have a volume, gallons per minute, and we just need to figure out what is the volume of this cylindrical tank. Well, volume of just anything, really, the volume of something is, an average area times an average height. It's area times height or area times depth. So what's the area of our cylinder? Well, since